Welcome to part 2 of the web series Artificial Intelligence Lab to Life, Hype to Reality. The AI Journey. The history of AI is a century old. It has gone through several ups and downs during this period. 1921 was when AI got a mention for the very first time in a play. The play had robots as its character who could think. Therefore, the concept of machines that can think started to appear in books quite frequently. The next 10 years, AI started to get real. Terms like machine learning got formally defined, and the famous Alan Turing test was proposed. The test proposed that if a machine can engage in a conversation with a human without being detected as a machine, then it has demonstrated human intelligence. The next 15 years came to be known as the first summer of AI. During this period, the language Lisp was invented. It became popular as a language for solving complex algebraic and mathematical operations. As a result, Lisp gave a huge push to AI research. After the summer came the first winter of AI in the late 1970s. Business and government lost interest in AI as there wasn't any hard evidence of a return of investment. As a result, investments dried up in research. But in early 1980s, things started to pick up again when Digital Equipment Corporation declared that its investment in an AI expert system had helped it save over $25 million annually. Research in AI once again got a boost. One of the fundamental methods for AI, called backpropagation, got published during this period. Then came the second winter of AI that lasted almost 25 years. While research continued at a slow pace and some of the AI experiments did produce some amazing results, like IBM's Deep Blue beating the Grandmaster in chess, AI systems were too expensive to be put to any commercial use. The last decade, since 2011, has seen AI take off in a big way because most of the impediments that were holding back the commercialization of AI got removed. We will go through them in greater detail in the next slide. The period of AI renaissance has finally arrived. It is very evident that there is going to be no turning back. There is a resounding belief and proof that AI systems will transform the world at an exponential scale. The challenges that are starting to take center stage now are: how can we ensure that AI doesn't get out of hand or get misused? How do we ensure that AI systems are fair, unbiased, robust, and explainable? And how do we ensure that humans do not become slaves to AI to a point that AI starts controlling humans? The optimism around the future of AI can be attributed to three enablers, or the three A's, namely accessibility, affordability, and adoption. Let's go through the top factors driving these three A's. The first factor is computer power. Increase in computational horsepower is driving the next generation of computer architecture that AI solutions need. Moore's law, that stated that the speed and capability of our computers will increase every couple of years at reduced cost, has been true for the last several decades. But with GPUs and quantum computers, we are already seeing exponential rise in computing speed and power, way beyond what Moore's law had predicted. The next factor is big data. Our ability to capture, store, and process not just structured data but also unstructured data digitally has given AI the teeth that it lacked earlier. We will see later that ML models are the engine that drive AI solutions, and models need data to train. The relationship between AI and big data is twofold. On one hand, big data is a prerequisite for AI, and on the other hand, AI solutions process big data to drive intelligence. The third factor is cloud computing. Computing has provided scalability and flexibility which is required to build and train AI ML models at low cost without huge upfront investments. Amazon AWS, Google Cloud Platform, Microsoft Azure, and IBM Cloud Pak for Data provide fully managed cloud infrastructure on the fly. The next factor is deep learning. Advancements in deep learning have accelerated AI adoption and accessibility. Artificial neural networks like CNNs and GANs that were buried in research papers and small scale experiments have now come to life with the availability of inexpensive compute and massively scalable cloud infrastructure. Techniques on transfer learning, unsupervised learning, and reinforcement learning offer advanced methods to build AI applications faster. Do not worry if you do not completely understand these terms and jargons. We will discuss them in subsequent parts of this mini series. The next factor is APIs, Application Programming Interfaces. Popularity of APIs provides the ability to integrate functionality of another program into your program without having to code it yourself. Since most of these programs and code is open source, it significantly reduces the time to build AI systems. For example, APIs are available for pre-trained out-of-the-box AI features for facial recognition, object detection, sentiment analysis, speech-to-text conversion, and most other cognitive functions. Open source ecosystem is an important factor. AI algorithms and framework are available publicly for free. For example, TensorFlow from Google is an open source AI machine learning framework available to all at zero cost. The last factor is Internet of Things. IoT provides the ability to connect all the devices and sensors of the internet. This provides an efficient way to generate and collect data of all kinds that can be consumed by building useful and practical AI applications. This data is available near real time and helps AI applications like self driving cars, intelligent homes, and offices. Each of these factors are going to further advance with time, resulting in accelerating the accessibility, affordability, and adoption of AI systems.